Alright, this is our continuation of lesson 2.2, where we're talking about basic differentiation rules. And rates of change. So we last video talked about the constant rule and the power rule and did some examples on how to apply them. We're going to start this video with a theorem, theorem 2.4, where we're calling this the constant multiple rule. And how we phrase this theorem, we say if f is a differentiable function and c is a real number, then c times f is also differentiable. And the derivative, which remember we can write as d over dx of c times the function f of x, it's really just going to be c times the derivative of the function. So let's look at some examples of how we would actually apply this. So continuing off the last example in the last video was example 4, this will be example 5. We're going to find f prime of x. We're just going to find the derivative. It could be y prime, t prime, whatever the function is. We're going to look at multiple examples of this, though. So the first one, we'll call it 5a. We're going to look at y equals 5x cubed. So if we're thinking about this constant multiple rule, 5 would be c, x cubed would be the f of x. If we want to find the derivative, we're going to go 5 times the derivative of x cubed. And from the power rule that we learned in our last video, the derivative of x cubed would be 3x squared. Then we just multiply these. So our final derivative is going to be 5 times 3, which is 15, x squared. And that's it. Let's look at another one. We'll call this one 5b. We're going to have the function y equals 2 over x, which we looked at some problems like this in our last video. We can rewrite this as 2x to the negative 1. So using this constant multiple idea, 2 is the c value, x to the negative 1, that's f of x. So if we're wanting to find the derivative, we're going to have to write it as 2 times the derivative of x to the negative 1 is going to be negative 1 times x to the negative 2. We're getting real close because now we can multiply in that 2. We can write this as negative 2 x to the negative 2, and then we take care of that negative exponent. So we can rewrite this as negative 2 over x to the positive 2. And we've found the derivative of 2 over x. Let's look at another one. So we'll call this example 5c. We're going to have f of t equals 4 t squared over 5. Now, we can actually write this as 4/5 t squared. So in this case, c is 4/5. So we're going to find the derivative, f prime, of t is going to be 4/5 times the derivative of t squared is going to just be 2t, and then we multiply this out. 4/5 times 2t, we could write 2t over 1. We don't have to. If we do that, we'd go 4 times 2t, so we're going to get 8t in the numerator over 5 times 1 is 5. So the derivative of 4t squared over 5 is going to be 8t over 5. Let's get another one, 5d. We're going to have y equals 2 square roots of x. We can rewrite this as 2x to the 1/2. In fact, we want to do that. So now when we find the derivative, we're going to have 2 times, we bring that 1/2 down, x to the negative 1/2. Now when we multiply 2 by that 1/2, that's just going to make 1. So we're going to have x to the negative 1/2, and then we take care of that negative exponent. So we can write this as 1 over x to the 1/2, which we can be done there. I'm totally fine with you stopping at that point. If you wanted to keep going, you could also write this as 1 over the square root of x, which is also an acceptable answer. I have 2 more little parts to look at in example 5. So let's look at them. So we're going to look at example 5e, where we're going to have y equals 1 over 2 cube roots of x squared. Let me clean that up a little bit. Alright, there we go. Now we can rewrite this as 1/2 times x to the negative 2/3. That 1/2 is our c value. Our function is x to the negative 2/3. So let's find the derivative. Let's find y prime. Y prime is going to be 1/2 times, we bring that negative 2/3 down, and then we take 1 from negative 2/3 for the power. So our power is going to become negative 5/3. Now we're almost done with this one. If we multiplied the 1/2 and the negative 2/3, those 2's, they're just going to cancel each other out. So we're going to have negative 1/3. And then let's take care of that negative exponent. We'll write that as 1 over x to the 5/3. And we're multiplying those two fractions. So we can write this as negative 1 over 3x to the 5/3, or if you wanted to go one step farther, you could write it as negative 1 over 3 cube roots of x to the 5th. I would take either of these as an answer. So you can give me either of those two. One more. Let's look at 5f. We're going to have y equals negative 3x over 2. Well, this is going to be y equals negative 3/2 times x, and if we find the derivative, we've got negative 3 halves times the derivative of x, which would be 1 times x to the 0, and anything to the 0 is 1. So our derivative is just going to be negative 3 halves. Now we're going to also look at some examples where we're going to use some parentheses when we differentiate, which we've actually been doing in here, but let's look at some more. So we're going to call this example 6, where we're going to use parentheses when differentiating. We're going to say we've got 4 examples to look at within example 6. We're going to have our first function be y equals 5 over 2x to the 3. Now we're going to start by rewriting this. We're going to write it as 5 halves, the constant parts, and then we're going to put some parentheses with our x, but if we're bringing that x to the 3 out of a denominator, we have to now make it a negative 3. So we've rewritten it. Now we're going to find the derivative. We're going to differentiate it. Y prime is going to equal, well, by that constant multiple rule, we're going to keep our 5 halves, but then we find the derivative of x to the negative 3. And by the constant, the power rule from our last video, that derivative is going to be negative 3 x to the negative 4. Now what we're going to do is we're going to simplify this. We're going to do any multiplying we need to do and put any negative exponents where they're supposed to be. So if we multiply 5 halves by negative 3, we're actually going to get negative 15 over 2. And then if we bring that negative exponent with that x to the negative 4 where it's supposed to be, we're actually going to put the x in the denominator and rewrite the 4 as a positive 4. So the derivative of 5 over 2x to the 3 is going to be negative 15 2x to the 4. Seems a little strange, but using these theorems and rules we've talked about, it actually does make sense. Let's look at 6b. We're going to have the function y equals 5, and this time we're going to have in the denominator in parentheses 2x to the power of 3. So we're going to start by rewriting this. We're going to use that power. So we can write this as 5 over, well, 2 to the power of 3 is 8. X to the power of 3 is x to the 3. Then this kind of looks like our last example. We can rewrite this as 5 over 8 times x to the negative 3. And then we can start differentiating. Y prime is going to be 5 over 8 times negative 3 x to the negative 4. Now we can simplify it. 5/8 times negative 3, that's going to give us negative 15 over 8. And if we bring that negative exponent where it's supposed to be, we bring it down to the denominator, and then we can make the exponent positive. So our answer is going to be negative 15 over 8x to the 4th. That is the derivative of 5 over, in parentheses, 2x, that whole quantity cubed. Let's look at 2 more. So 6c, we're looking at the function y equals 7 over 3x the negative 2. So let's start by rewriting this. We don't like having negative powers. So we can move that negative power to the numerator, and the power will become positive. So this will be 7x squared over 3. Now we can differentiate it. So y prime is going to be 7/3 times, if we find the derivative of x to the power of 2, we're just going to have 2x. Now we can multiply. 2 times 7 is 14. So we're going to have 14x over 3 for our derivative. If you hear a little snoring in the background, that's been my dog. One last part to example 6. We're going to look at part D, where the function is going to be y equals 7 over, and this time we're going to have the 3x in parentheses, and that's going to be raised to the negative 2. So we're going to, just like the last one, start by rewriting this, bringing any negative powers to the numerator. So this is going to be 7 times 3x to the power of 2. Now with order of operations, we do need to start by using our exponents. So we can still simplify this a little bit more. We can write this as 7 times 3 squared is 9x squared. And yet we can still simplify this a little more. We can actually do 7 times 9. So this is still going to simplify to 63x squared. And we're almost done because now we can actually start differentiating it. Y prime is going to be 63 times 2x, which means the derivative is going to be 126x. And we finished it. We don't have time to look at the next theorem and the examples, in fact the next 2 theorems and the examples that would go along with them. We're going to try to get those in the next video.